So today we're going to talk about relative velocity, and it's similar to what we talked about last week, all right? So here's a bus, okay, and it's traveling down the road, and let's say it's going to the right, so that's going to be positive velocity, and it's going to the right. And from reading this, remember relative velocity is always measured from something, okay? So you always have to reference to what you're measuring the velocity in respect to or relative to, okay? So here we have a bus, and we have a person on this bus that is walking in the same direction the bus is traveling, okay? And they tell you the person relative to the seat, which is also, the seat is part of the bus, so it's also relative to the bus, okay? This person right here is traveling, okay, walking down the aisle, and they're traveling at 1 kilometer per hour. But then then the bus is traveling at 100 kilometers per hour, okay? And so this one is 100 kilometers per hour. And that's actually relative to this ground, okay? Now, there's a couple things, and this is what's weird about all this. And I'm going to talk more about this in just a minute, okay? But this person is moving to, relative to the bus, they're moving to the right, okay? So that's why I'm positive velocity. Now, relative to the person, the bus is actually moving to the left 1 kilometer per hour. And that's what's kind of crazy, okay? Relative to one, it's positive 1, and relative to the other, it's going to be a negative 1, okay? So if you flip them, all right, it's going to make the velocity be negative, okay? So here, the bus is moving to the right, and I think it's easier to explain this one, okay? So the bus is, compared to this road, the bus is moving to the right 100 kilometers per hour. Now the road, if you're on the bus, the road relative to the bus would be traveling negative 100 kilometers per hour. So this road is moving to the left because the bus is moving to the right. Okay, this is kind of some crazy stuff, okay? All right? Okay, so we brought into this notation, the velocities are vectors. That's why these are bold-faced. Vectors are a lot of times we use bold-face for vectors, okay? This PB, okay, represents the velocity, and V sub PB is the velocity of the person. So I'm going to write this. The velocity of the passenger or the person relative to the bus. So in this case, P stands for person and B stands for the bus, okay? This is the object that's moving. And this is what it's relative to this object. Okay, so the first letter is the object that's moving, and we're explaining the movement relative to this other object. Okay, and so we know from this that this measurement is 1 kilometer per hour, and that was given to us. Okay, so what's going to be really important about these problems is you figure out which of the velocities is given to us. Okay, and then I'm going to show you a way on how to calculate other velocities that aren't given to us. Okay, so this is the velocity of the bus relative to the road. Okay, so the velocity of the bus relative to the road, and R stands for road. B still stands for bus. So now the bus is the object that's moving, and we're describing how it's moving relative to that road, and it's moving to the right of the road, okay? So then this would be equal to 100 kilometers per hour, and that one was also given to us. Okay, based on the givens, the velocities that are given to us, we can calculate other velocities, okay? So like I said earlier, okay, we can actually calculate the velocity of the bus relative to the person, okay? So velocity of the bus relative to the person would be -1 kilometer per hour. Okay. Now, notice what happened is these switched, right? If you know one of them, you can write that tells us we can write the other one, but we have to take the negative of it, okay? So in this case, velocity of the bus relative to the road, we could figure out the velocity of the road relative to the bus. It would simply be -100 kilometers per hour. Okay. So that's what I'm saying is if you have one of these, you can get the other one by just flip-flopping it and taking the opposite. Okay. A simple way of saying this is the velocity PB is equal to negative velocity of, actually, I wrote that wrong. Let me fix that. The velocity of BP, we can calculate that one by taking the negative velocity of PB, okay? And here, VRB, we can get by taking negative the velocity of BR, okay? So now, what does this one represent? This is one that's not given to us, but we can still calculate it, okay? And I bet some of you, just kind of through common sense, you can kind of figure this one out. This is the velocity of the person relative to the road. Okay, so let's write that. The velocity of the person relative to the road. All right, and so we look at this and we go, okay, the bus is going 100, so that person's going 100, but then they're going one more, right? So the velocity of the person with respect to the road would be 101 kilometers per hour. And that was actually calculated. That's supposed to be a C right there. All right. Not calculated, it's calculated, okay? So we calculate that velocity, all right? And because we have that calculated velocity, we can get the velocity of the road with respect to the person. And this is an important idea that we're going to need to use, okay? So this would be equal to negative of the velocity of the person with respect to the road. So that would be negative, since we know this one's 101, this would be negative 101 kilometers per hour because it's going in the opposite direction. Okay? All right, so what's hard about this is this one was pretty easy because everything's going in the same direction. But what happens is sometimes you add these and sometimes you subtract these, and it's really going to be hard, okay, when we go to like 3 different objects. All right, so I'm going to give you problems where you have 3 different objects that are moving, and you have to say the velocity of one with respect to the other. Okay, and if you follow my lead, all right, and you're organized, you're going to be able to get this fairly easily, I think. Okay. So I'm going to jump down here to these first, and then we'll come back and talk about this equation right here. And this is actually the equation that we need. Okay. So and the order here all matters. Okay. So remember, this is the velocity of object A with relative to object B. So this is the velocity of object A relative to object B. And then this one is the velocity of object B. Okay, so relative to object C. And then this one would represent the velocity of object A relative to object C. Okay, so basically it's this. If you want to find the velocity of an object relative to another, okay, and you don't have it, it wasn't given to you, you can calculate it, okay? Now what you have to do is if you want to find the velocity of object A with relative to C, and you're going to hear me sometimes say with respect to, that's also relative to, okay? So the velocity, to get this one, we have to know the velocity of object A relative to B, and then we also need to know the velocity of object B relative to C. Now, this is what's important. You notice that these, and what happens is, I don't want to say it quite like this, but I'm just going to say it because I think you'll understand a little bit better. What happens is the B's cancel out, but they have to be in this order. So if I want to write this, like let's say I want to know the velocity of object A relative to D, then what I would need to do is I would need to find the velocity of object A relative to B, add that to the velocity of object B relative to C, and then add to that the velocity of object C relative to D. So this is going to be the object. Okay, so in this equation, this one right here needs to be the object we're finding the velocity, okay, of. And then this last one has to be the object it's relative to. Okay, and you have to go B and then B to C and then C to D. So if we were to do velocity of object A to F relative to F, then that would be VAB plus VBC plus VCD plus VDF. And so we have to start with the object that we're finding the velocity of, and we have to end with what it's relative to, and everything in between is going to cancel. Now, we're going to have to do some things in here to clean this up, but this is going to be the equation that we always start with, okay? And this is the one that we're trying to find, and we're going to need to be given all of these, okay? All right. So the image I got this from, I wish it was going the other direction, but it's not, okay? So this ball is moving to the left. So I'm going to say to the left, like traditionally, okay, going left would be negative velocity, and going to the right would be positive velocity, okay? So here we go. Suppose a friend always pitches a baseball at the same speed of 60 kilometers per hour, okay? So I'm going to call this person right here the pitcher. And this is the ball. And this is the catcher. Okay, and obviously this is the truck. Okay, so now what we would say is the velocity of the ball relative to the pitcher. So the velocity of the ball relative to the pitcher would be equal to, and since we're going left and the speed is 60 kilometers per hour, this is going to be negative 60 kilometers per hour. Okay, now this is going to be important. What if we don't want this one? Okay, and the truck's at rest. Okay, so I'm also going to say this is the ground. So we could also say that. Or earth, sometimes you'll see I'm relative to the earth. Ground and earth are the same thing. All right. So because the truck's not moving, we can also do, so the pitcher's not moving, the truck's not moving, and that means all the pitcher, the truck, and the ground would be all at the same, relative to the same thing, okay? Because none of those are moving. It's kind of like this. You're sitting in your room right now, okay? And you look around and everything's moving the same speed, right? It looks like you've stopped, okay? All of these are moving at the same speed, okay? Which is 0 in this case, all right? So we could also say the velocity of the ball relative to the ground is also equal to negative 60 kilometers per hour, which means we could find, all right, the velocity of the pitcher relative to the ball. Okay, so the velocity of the pitcher relative to the ball, and we're going to need to, sometimes we're going to be given this, but we need this one. Okay, so because we're switching these, that's just negative of the velocity of BP, which turns out to be negative 60 kilometers per hour. And we could also find the velocity of the ground relative to the ball. You know what? I'm sorry. This would be negative of negative 60. Let me fix this. It'd be negative of, because this one's negative 60. And so that would give you positive 60 kilometers per hour. Okay, because the ball relative to the ground, the ball is moving left, but the ground relative to the ball, the ground is moving right, because the two things are gonna go in opposite directions of each other. Okay, so the velocity of the ground relative to the ball, okay, would be negative the velocity of BG, which would be negative, and since BG is negative 60, that'd be negative of negative 60 kilometers per hour, which would give you positive 60 kilometers per hour. Okay. All right. So now let's do some problems where multiple things are moving. This was just one thing's moving, the ball. All right. So this is going to be really important. I can't stress this enough, that you understand this idea that if I give you the velocity of the ball with respect or relative to the person or the pitcher, okay, you can also give me the velocity of the pitcher relative to the ball. Okay. All right. So let's go to the next problem that's on the next page. Okay. So now we're going to have two things moving, the ball and also the truck. Now the pitcher now becomes part of the truck. The pitcher is not moving. Okay. So now suppose your friend pitches the ball to you from the flatbed of a truck that moves towards you at 40 kilometers per hour. Okay. So the person and the truck become one thing because they're not moving. They're moving. They're together. They're not moving. The pitcher is not moving relative to the truck at all. Okay. All right. So what we want to figure out is what is the velocity of the ball relative to the ground. Okay. So I know the velocity of the ball relative to the truck. And because it's going to the left, it's going negative 60 kilometers per hour. Because remember from the last one, the pitcher always pitches it at 60 kilometers per hour. Okay. Now, the velocity of the truck relative to the ground, it would be going negative 40 because the truck is also going in the same direction. Okay. So it's going towards this person right here. Okay, so that's negative 40 kilometers per hour. So I want to find the velocity of the ball relative to the ground. Okay, and so we can do that because the velocity of the ball relative to the ground, we know the velocity of the ball relative to the truck. And we can add to that the velocity of the truck relative to the ground, because we started with the velocity that we're trying to find of the ball, and relative to the ground, that's the last thing here, okay? So that means this VBT is negative 60 miles per hour. And I'm doing one that's simple that you might not need this equation for, and I realize this. So this is negative 60 kilometers per hour. And we're going to add to that the velocity of the truck relative to the ground. So that'd be negative 40 kilometers per hour. And so we have negative 60 plus a negative 40. So that'd be negative 100 kilometers per hour. Okay. So the velocity of the ball relative to the ground would be negative 100 kilometers per hour. Okay, let's go to the next one. So for this one, suppose the truck now moves away from this person that's catcher, okay, at 40 kilometers per hour, and your friend again pitches the ball to you, okay? So again, the ball is going left, so that's gonna be a negative velocity. Now the truck is moving to right, so that's gonna be a positive velocity, okay? So the velocity of the ball relative to the truck would be negative 60 kilometers per hour. The velocity of the truck relative to the ground would be positive 40 kilometers per hour. And so we know that if we want to find the velocity of the ball relative to the ground, we can do that by taking the velocity of the ball relative to the ground is equal to the velocity of the ball relative to the truck, and adding to that the velocity of the truck relative to the ground. So this one is negative 60 kilometers per hour plus the velocity of the truck relative to the ground would be positive 40 kilometers per hour. So that means the velocity of the ball relative to the ground would be negative 60 plus 40, which would be negative 20. So negative 20 kilometers per hour. All right. So let's go and let's start doing a little bit harder problems that will allow us to use these equations. And some of them it's going to be a necessity to write this equation. So I'm going to require you guys, you have to write the equation on your homework problems, okay? So you got to write this equation and then write what you know, okay? And you're going to see me model it with the next few examples, okay? Write what you know, write the equation, and then plug everything in and solve. All right, so here I'm doing one that's fairly simple, okay? A couple things, the direction east, west, north, south will tell us whether the velocity is positive or negative, okay? So remember, north is up, south is down, west is left, and east is right. So going east is positive, going north is positive, going west is negative, and going south is negative, okay? So car A travels east at 80 kilometers per hour. Okay, now it's not saying what it's relative to. So when it doesn't say, you can assume it's relative to the ground, okay, or the road, okay? So what's given right here, car A travels east at 80 kilometers. Since we're going east, that's going to be a positive 80, okay? And car B travels at 90 kilometers per hour in the same direction. So that means it's also traveling east. So what was given here is the velocity of car A relative to the ground or road or earth, okay? So that would equal, since we're going east, that's 80 kilometers per hour. All right, and then we also know the velocity of car B travels at 90 kilometers per hour in the same direction. So that's the velocity of B relative to the ground again, because it doesn't say what it's relative to, so you can automatically assume it's the ground. So the velocity of car B relative to the ground is 90 kilometers per hour. And what we're trying to find is the velocity of car B relative to car A. So we're trying to find the velocity of car B, so we start with a B, relative to A. Okay, so there's this in between, that's the ground, right? So we can write the equation, the velocity of car B relative to A is equal to the velocity of car B relative to the ground. And we have that one, right? That one's going to be nice. See, we can do the substitution right there. Plus the velocity of and we would need to write the ground relative to A, and we need to end it with A. And the G needs to be the last one here, but the first one here, okay? Now, we weren't given this, right? But we can calculate it, because if we know the velocity of A relative to G, we know the velocity of G relative to A would have to equal, okay, negative velocity of object A or car A relative to the ground. So that would be negative 80 kilometers per hour. So the velocity of car B relative to A would be V, the velocity of the car B relative to G, which would be 90 kilometers per hour, plus, and we know the velocity of the ground relative to A is negative 80. And so positive 90 plus negative 80 gives you 10. And the velocity of car B relative to car A would be 10 kilometers per hour. Now, I probably realize, Mr. Mitchell, I didn't have to do all that work. I realize that, but when the problems get really complicated, you are going to need to do that. Okay, so learn how to do this equation with simple ones, and then we do when we do the more complex ones, and I will test you on the more complex ones. Okay, because I want to know that you know this equation right here. Okay, this also has to do with Einstein's theory of relativity and a whole bunch of other things that's going to lead. This is leading up to something. Okay. All right. So learn the equations and how to use them. All right. That's my point. Okay. Even though I realize you could probably go, wait, that one's just going 10 miles per hour faster. Yeah, but a lot of times do you add, do you subtract? Which one's positive? Which one's negative? Should this have been negative 10? Should it have been positive 10? And so it's all, you can get it right if you write these equations. Okay. And that's my point. Okay, so car A in this next example, car A travels east at 80 kilometers per hour, and car B travels 90 kilometers per hour in the opposite direction. What is the velocity of car B relative to car A? Okay, so do you add these? Do you subtract them? What do you do? Okay, so what we're given here is car A is traveling east, so we know east is going to be positive, and we know it's going positive 80 kilometers per hour, and that's relative to the ground. So once again, it's the same. This starts out being the same with car A. So car A relative to the ground is equal to 80 kilometers per hour. The velocity of a car B, it's traveling 90, but in the opposite direction. Okay, so the velocity of car B relative to the ground, and because it's going in the opposite direction, that means it's going to be a negative of this velocity. Okay, so that's going to be negative 90 kilometers per hour. So if this one's going east, this one, you can also figure out this way. This one, if car A is going east and they're going in opposite directions, car B would have to be traveling west. That's why it has a negative velocity attached to it, okay? And once again, we want to find the velocity of car B relative to car A. So that we want to find the velocity of car B relative to car A. All right, so we can do it this way, all right? So we're gonna have the velocity of car B relative to A, we can get, and the thing it's connected is the ground, right? So we can relate this to the velocity with relative to the ground. So the velocity of car B relative to the ground plus the velocity of the ground relative to car A. Once again, we don't have the velocity of the ground relative to car A, but we have the velocity of car A relative to the ground. So the velocity of the ground relative to car A would just simply be negative 80 kilometers per hour. It's always going to be the opposite, right? If we flip it, it's going to change the signs of it basically, okay? So the velocity of car B relative to A would be the velocity of car B relative to the ground, which is negative. We have that one, so that's negative 90 kilometers per hour. And I'm going to put parentheses around this. and we're going to add to that the velocity of the ground relative to car A, which is negative 80 kilometers per hour. And so we have negative 90 and negative 80, which winds up being negative 170. So the velocity of car B relative to A would be negative 170 kilometers per hour. So see, some of us, you might go, oh, I knew to add that, so I just said it was going to be 170. Well, you'd be wrong because it's actually negative 170. So writing this out will get you the right sign. So I'm sure some of you are looking at this and go, oh, I can get that without doing the equation. I realize that. And that's good, except a lot of times if you don't write the equation, a lot of times people get the signs wrong, okay? All right, and that's a big deal, okay? All right. Let's do the last problem, which is a more complex version of this. Okay, so here I'm having three things moving, okay? And this is where you really need to have the equation, okay? So a train travels east at 100 kilometers per hour, okay? A person inside the train walks in the opposite direction of the train at 5 kilometers per hour. So that's actually gonna wind up being negative 5 kilometers per hour relative to the train. And then a car is traveling east at 30 kilometers per hour relative to the ground. Okay, and I could have also said the car is traveling east at 30 kilometers per hour and not have said relative to the ground at all, and you just know it's relative to the ground, okay? What is the velocity of the person inside the train relative to the car, okay? And so you could do any combination of two of these, right? What's the velocity of the train relative to the car? What's the velocity of the person walking relative to the, well, that one was given. Some of them are given, okay? And then some of them you can just calculate, all right? All right, so let's start by writing what we know, okay? So we know a train travels east. So traveling east is gonna cause it to be positive, and that's gonna be positive 100 kilometers per hour. And because it's not saying what it's relative to the ground. So let's use T for train. Let's use P for person and C for car. Okay, so T is equal to the train. P is the person walking on the train. And then C is the car. And G is ground. You could also call that earth or train tracks, okay? All right, so a train travels east at 100 kilometers per hour. So that'd be the velocity of the train relative to the ground. So that'd be velocity of TG, and that would be 100 kilometers per hour. We know the person in the train, inside the train, walks in the opposite direction of the train. So if the velocity of the train's positive, if they're going in the opposite direction, this is going to have to be negative, okay? So that's the velocity of the person relative to the train. So that's V sub PT. And we know that's negative 5 kilometers per hour. All right. And then we know the car is traveling east. And since it's traveling east, we know that's going to be positive and it's relative to the ground. So that'd be the velocity of the car relative to the ground. And that's going to equal positive 30 kilometers per hour. Okay. And what do we want to find? Okay. We want to find what is the velocity of the person inside the train relative to the car. So we want to find the velocity of P relative to the car. So we want to find V sub PC, right? What is this equal to? All right, so here we go. Okay, so we need to start with something with P, right? And so we have this one. So V sub PC, the velocity of the person relative to the car, would equal the velocity of the person relative to the train. And then we can relate that to the ground. So plus the velocity of the train relative to the ground. And then we need to end it with c, right? So that would be the plus the velocity of the ground relative to the car. Now we have this one, right? That's -5. We have this one, that's 100. We don't have this one, right? But we can get it because we have the velocity of the car relative to g. So we know the velocity of the ground relative to the car would have to be equal to -30 kilometers per hour. So if you have one of these, you've got another one too, right? So the velocity of the person relative to the car would equal the velocity of the person relative to the train, which is -5 kilometers per hour, plus the velocity of the train relative to the ground, which is 100 kilometers per hour. And then plus, and the velocity of the ground relative to the car, which is -30 kilometers per hour. Okay, so if you combine -5 plus 100 plus -30, right? That would give you not negative, it'd give you positive. So the velocity of the person relative to the car is equal to, and this would be 65 kilometers per hour. So that means the person relative to somebody in the car, that person, if you like, let's say you're in the car, that person on the train looks like they're traveling 65 kilometers per hour to the east. Okay, that's what this is telling us. Okay, so that's like you sitting in the car looking at the person in the train. They look like they're moving 65 kilometers per hour to the east. Okay, and that's how you do it. All right, so this is where it's really important you write these equations. Okay, all right, I'm going to have to give you no credit, all right, if you don't write these equations, because that's what's very, very important is you write these equations. Okay, remember, you have to start with the first letter and you have to end with the last letter and connect everything in between, right? P, T, T, G, G, C, right? And the T's and the G's would cancel each other out, and you're left with the velocity of P relative to C, which is the velocity of the person relative to the car. All right. All right, guys, that's it for today. Let's meet back, okay? And we'll discuss this a little bit further. I'll do another example live with you guys.